Section 4.4, non-homogeneous equations, undetermined coefficients. For a non-homogeneous ordinary differential equation of the form ay double prime by prime plus cy equals to f of x, where f of x is different to 0, the solution would be y equals to yc plus yp. Yc is the solution of the homogeneous equation. And remember, the solution of the homogeneous equation is coming from the solution of the auxiliary or complementary equation. And yp is going to be the solution of or it's going to be better, the particular solution. And this particular solution is going to come from f of x. So the undetermined coefficient is going to help us to find yp, the particular solution. Finding the particular solution involves three cases. One case is if we have on the right an expression like this: cx to the m e to r x, cm to the x r e to r x. M is a positive integer. Remember, a positive integer is a positive whole number and also 0. So m may take the values 0, 1, 2, 3, 4, 5, 6, 7, 8. That is whole positive numbers. Now, if we have an expression as the one I shaded in blue, the solution, the particular solution, is going to have this form: x to the s times a polynomial which greater expression is depending on x to the m and multiplying an exponential term, rx. Now, something to observe. If m is 0, okay, then we will have no polynomial multiplying. But we may have a term x to the s. How we can form this term? Well, s could be 0, 1, or 2, depending on what? Depending on the r of the exponential. These are. If these are is not a root of the associated auxiliary equation, then s would be 0. If r of the given exponential is a simple root of the associated auxiliary equation, then s would be 1. If r is a double root of the associated auxiliary equation, then s would be 2. The second case involves, on the right, a polynomial term or a power term. Remember, m is a positive whole number, an exponential term, and a trigonometric function that could be either cosine or sine, or maybe the sum of the two, a linear combination. So the solution is going to be like the one I'm shading now in yellow. It's going to be the sum of two terms, both of them containing x to the s, a polynomial which greater degree is going to be m, an exponential and a trigonometric function, and the value of s is going to be either 0 or 1. Okay? If alpha plus I beta is not a root associated to the auxiliary equation, then s would be 0. Is as is 1 is because alpha plus I beta is the root of the associated auxiliary equation. And it is important to state that this letter should be t or x. So could be like this also t, or could be like this, x to the m e to rx cosine of beta x, or c x to the m e to rx sine, okay, of beta x. Okay, so what I'm saying is that the independent variable, the independent variable is either x or t. Okay, so the solution is going to depend on x or is going to depend on t, depending on the what is given in the problem. Finally, case 3. Case 3 is the case that on the right we have a polynomial function only. If we have a polynomial function only, then the solution is going to be a polynomial of the same degree of the given polynomial on the right. Okay, and now we are going to show some problems relating this method.